There's a smell every farmer who's ever put up hay knows. It's the smell of fresh-cut alfalfa drying in the summer sun, mixed with diesel exhaust, dust, and sweat. It's the smell of racing against the afternoon thunderstorms, of long days that start at dawn and end after dark, of work that has to get done because winter is coming and animals need to eat. For generations, hay season meant back-breaking labor, pitchforks, wagons, and manual stacking in barns that turned into ovens under the summer sun. Then came the baler. These machines didn't just make hay farming easier. They revolutionized livestock agriculture, made dairy farming economically viable, and changed the entire structure of American farming. Today, we're counting down the top 10 most powerful vintage hay balers that revolutionized livestock farming. From the pioneering square balers that freed farmers from pitchforks, to the revolutionary round balers that changed hay storage forever, each machine on this list transformed how farmers worked and how animals ate. Let's dive in. Number 10, New Holland Model 68. Hayliner. Coming in at number 10 is the New Holland Model 68 Hayliner, introduced in the late 1940s and representing New Holland's breakthrough into serious baling equipment. Before the Model 68, New Holland had experimented with various designs, but the 68 was the machine that convinced farmers mechanical baling was the future. The Model 68 was a pull-type baler featuring New Holland's proven pickup mechanism that gathered cut hay from windrows, feeding it into the compression chamber where a reciprocating plunger compressed hay into rectangular bales. It produced what we'd call small square bales today, typically 14 by 18 inches, tied with twine, weighing 40 to 80 pounds depending on hay type. What made the Model 68 special was reliability. New Holland engineered it with robust components that could handle 12 to 14-hour days, 6 or 7 days a week, processing thousands of bales. The pickup tines were spring-loaded to handle uneven windrows. The plunger was driven by a massive flywheel that stored energy between strokes. The knotters, the mechanisms that tied twine around each bale, were New Holland's pride, capable of tying thousands of knots without missing. Farmers who bought Model 68s typically reported processing 300 to 500 bales per day in good conditions, a massive improvement over manual handling. You could cut hay in the morning, let it dry through the afternoon, and have it baled and in the barn by evening. This speed mattered enormously. Weather determines everything in hay farming, and the ability to process hay quickly meant better quality and less weather risk. The Model 68 found particular success in dairy country, Wisconsin, New York, Pennsylvania, where farmers needed high-quality hay for milk production. Production continued until 1953, with thousands built. Many logged over 20 seasons before retirement. The Model 68 proved self-propelled harvesting wasn't just possible, it was the future. Number 9, International Harvester 46 Baler. At number 9, we have the IH-46 baler, introduced in 1952 and representing International's determination to compete in every segment of farm equipment. IH had dominated tractors and combines, but hay equipment had been New Holland's territory. The 46 was International's statement that they could build balers as good as anyone. The IH-46 was a conventional pull-type square baler, but International brought their legendary build quality. The frame was heavy-gauge steel, overbuilt by standards of the era. The pickup mechanism used International's patented floating pickup design that adjusted automatically to ground contours, gathering hay cleanly even in rough fields. What really distinguished the 46 was the knotter design. IH engineers had studied every baler on the market and designed what they believed was the most reliable knotter mechanism available. It used fewer moving parts than competitive designs, reducing potential failure points. The twine path was simplified, reducing friction and wear. The result was a knotter that could run all day without adjustment. International marketed the 46 aggressively through their extensive dealer network, and it gained market share quickly. Farmers appreciated International's parts availability and service support when something broke during hay season, and something always broke. Bite dealers could usually get parts within 24 hours. This reliability of support mattered as much as machine reliability. The 46 found success particularly in beef cattle regions, The Great Plains, Texas, the Midwest, where ranchers were transitioning from loose hay to baled hay for winter feeding. Production continued through the late 1950s, and many remained in service into the 1970s. Today, collectors value IH-46 balers for their robust construction and distinctive IH red paint. Number 8. John Deere 14T baler. Moving up to number 8, we're looking at the Model 14T baler, introduced in 1954 and representing Deere's typically methodical approach. John Deere didn't rush into hay balers. They watched New Holland and International establish the market, learned from early designs, then introduced a baler that incorporated improvements based on years of observation. The 14T featured John Deere's signature green and yellow paint and legendary attention to detail. The pickup mechanism used Deere's floating pickup design with wide tines that gathered hay gently, reducing leaf loss, critical for maintaining hay quality. Alfalfa and clover hay lose much nutritional value if leaves are knocked off during baling, and Deere engineers obsessed over minimizing this loss. The plunger and compression system was driven by a substantial flywheel that Deere sized conservatively, probably bigger and heavier than strictly necessary, but providing absolutely consistent power. But the 14T's real innovation was the knotters. John Deere engineers designed knotters that were mechanically simpler than competitors but functionally superior. The Deere knotters had fewer parts, used larger bearings, and incorporated better lubrication systems. The result was legendary reliability. Farmers reported running 14Ts through entire seasons without a single missed knot if properly maintained. John Deere's dealer network gave the 14T enormous advantage. Deere dealers prided themselves on service, and during hay season they kept common parts in stock for emergency repairs. This dealer support, combined with inherent reliability, made the 14T extraordinarily popular. Production continued through the early 1960s, with many 14Ts remaining in operation for decades. Today, a working John Deere 14T is prized equipment. The 14T represents Deere's philosophy perfectly. Watch, learn, then build it better and support it completely. Number 7. Massey Ferguson 10 baler. At number 7 is the Massey Ferguson 10 baler, introduced in 1958 and representing Massey's global approach to agricultural equipment. Massey Ferguson was truly international, selling worldwide, and the Model 10 reflected design thinking influenced by European and North American practices. The MF10 was designed for easy maintenance. Massey engineers recognized that farmers worldwide might have limited dealer access, so they designed the 10 for owner maintenance. Major components were easily accessible. Adjustment points were clearly marked. The operator's manual included detailed troubleshooting and assuming farmers would do their own repairs. The pickup system used wider tine spacing than most competitors, designed to handle heavier crops in wetter conditions. In European farming, hay was sometimes baled at higher moisture content, and the MF10's pickup accommodated this. The wider spacing also meant less plugging and heavy windrows. The plunger drive used a simpler belt system, again reflecting maintainability focus. Belts were easier to replace than chains or gears. The MF10 produced standard small square bales and was rated for 300 to 500 bales per day. But where it really shined was versatility. The machine handled different crop types well: grass hay, alfalfa, straw, even some forage crops. This versatility made it popular on diversified farms in international markets, where farmers might bale various crops throughout the season. Massey Ferguson's global dealer network meant the Model 10 sold not just in North America, but in Europe, Australia, South America, and anywhere Massey had distribution. Production continued through the 1960s. Today, MF10 balers are appreciated by collectors and small farmers who value their straightforward, maintainable design. The Model 10 proved that sometimes the best machine isn't the fanciest. It's the one designed for real conditions. Number 6, Vermeer 605 Series Round baler. Breaking into our top 5 at number 6 is the Vermeer 605 Series Round baler, introduced in the 1970s and representing a complete revolution in hay baling. Before Vermeer pioneered practical round balers, virtually all hay was baled in small squares. Round bales had been attempted before, But Vermeer's design was the first that really worked for commercial agriculture. The 605 series featured Vermeer's belt-driven baling chamber, where hay was picked up from the windrow and rolled into a cylindrical bale as continuous belts rotated around the growing bale. The process was fundamentally different from square baling. Instead of compressing hay into a plunger chamber and tying individual bales, the round baler continuously rolled hay into an ever larger cylinder until the chamber was full. The bales produced were typically 4 to 5 feet in diameter and width, weighing 800 to 200 pounds. This was revolutionary. One round bale equaled roughly 15 to 20 small square bales. A farmer who previously handled 500 small squares, lifting each multiple times, could now handle the equivalent in 30 round bales, mostly moved with tractor loaders rather than manual labor. But it wasn't just about reduced handling. Round bales had storage advantages. Their cylindrical shape shed water when stored outside. The outer layer weathered and sealed, protecting the interior. Farmers could stack round bales in fields and leave them all winter, feeding directly from the field. Square bales required barn storage or tarping. The infrastructure savings were significant. Many farmers could eliminate hay barns entirely. Vermeer marketed the 605 aggressively, essentially creating a market that didn't exist. Many farmers were skeptical initially, but farmers who tried them became converts. The labor savings alone justified the investment within a season or two. The 605 series wasn't the most powerful baler by horsepower, but its impact was revolutionary. By the 1980s, round balers were outselling square balers in many markets. Vermeer's innovation fundamentally changed hay farming. Number 5. New Holland 316 baler. Coming in at number 5 is the New Holland 316. Introduced in 1968 and representing the pinnacle of small, square baler technology before round balers began dominating. The 316 wasn't revolutionary in concept. It was a conventional square baler, but it was executed with such refinement that it became the standard against which all other square balers were measured. The 316 featured an upgraded pickup with 80-inch width, wider than previous models, allowing faster ground speeds. The tines were precisely engineered for minimal crop loss, particularly important for leafy crops like alfalfa, where nutritional value resided in leaves. New Holland claimed their pickup design reduced leaf loss by 30% compared to competitive balers, a claim supported by university extension testing. The plunger system featured New Holland's patented soft start design that reduced shock loads on the tractor PTO. Anyone who's operated a square baler knows the characteristic ka-chunk rhythm as the plunger strokes. That shock load can be hard on tractor drivetrain components. New Holland's soft start system smoothed the power demand, reducing wear on both baler and tractor. The 316's knotters were essentially perfected versions of designs New Holland had refined for decades. They tied with remarkable consistency. Operators reported thousands of bales between missed knots if properly maintained. The 316 was rated for higher capacity than previous models, capable of processing 10 to 15 tons per hour, translating to 600 to 800 bales per day. New Holland marketed the 316 heavily to dairy farmers, emphasizing hay quality preservation. The machine became standard equipment on progressive dairy farms throughout the Northeast and Upper Midwest. The 316 remained in production through the 1970s and early 1980s, even as round balers gained market share. Today, vintage 316 balers are highly sought after. The machine represents the peak of square baler refinement. Number 4. Heston 5800 round baler. At number 4, we're looking at the Heston 5800, introduced in 1977 and representing a different approach to round baling than Vermeer's belt system. Heston pioneered the roll belt design that many manufacturers eventually adopted, proving there was more than one way to make a round bale. The Heston 5800 used multiple individual rubber belts running on rollers. As hay entered the chamber, these belts began rolling it into a cylinder. The advantage was flexibility. The roll belt system could accommodate varying crop density more easily than some competing designs. The disadvantage was complexity. More moving parts meant more potential maintenance. But Heston engineered the 5800 with remarkable reliability despite complexity. The belt tensioning system was sophisticated, automatically adjusting to maintain consistent pressure as the bale grew. The drive system used heavy chains and sprockets designed for long service life. The pickup featured Heston's wide throat design that could handle very heavy windrows without plugging. The 5800 produced bales similar in size to competitive round balers, typically 4 to 5 feet in diameter and width, weighing 900 to 1,200 pounds. But the bale shape was notably rounder and more uniform than some competing designs. This mattered for storage and handling. Truly round bales stacked better and rolled more predictably. What really set the 5800 apart was Heston's sophisticated monitoring and control system. Operators could set desired bale size and density, and the machine systems automatically achieved those parameters. The twine wrapping system wrapped twine in a precise pattern, ensuring the bale held together during handling and storage. Heston marketed the 5800 as the thinking farmer's round baler, emphasizing sophistication and control systems. The machine found particular success in the Great Plains and Midwest, where large-scale operations valued consistency. The 5800 proved that round baling technology could evolve, with multiple valid approaches to solving the same problem. Number 3. John Deere 535 round baler. Breaking into our top 3 at number 3, the John Deere 535 round baler. Introduced in the early 1980s and representing Deere's entry into round baling after watching the market develop. True to form, John Deere didn't rush. They waited until round baling was proven, then introduced a machine that incorporated the best ideas from competing designs, plus Deere's own innovations. The 535 used a variable chamber design, somewhat different from both Vermeer's belt system and Heston's roll belt approach. Deere's system used a combination of fixed and movable components that allowed the baling chamber to expand as the bale grew. This provided excellent bale density control and resulted in bales with very consistent shape and density. John Deere's legendary reliability showed in the 535's construction. The frame was heavy-gauge steel, overbuilt by industry standards. The pickup mechanism used Deere's proven floating pickup design. The belt or roller system used oversized components designed for long service life. Bearings were large and well sealed against dust and debris. One innovation the 535 pioneered was Deere's MaxiWrap twine application system. Instead of simply wrapping bales with twine in a basic pattern, MaxiWrap distributed twine across the bale surface more extensively, providing superior weather protection and bale integrity. This made Deere's bales notably more resistant to weather damage during outdoor storage. The 535 was rated for impressive capacity. Farmers reported making 30 to 40 bales per hour in good conditions, significantly faster than many competing round balers. John Deere's dealer network gave the 535 enormous advantages. During hay season, when downtime meant lost income, this support was invaluable. The 535 found success everywhere. Deere sold equipment, but particularly in the Midwest and Great Plains. Many 535s remain in service today, testament to Deere's build quality. Number 2, New Holland 855 round baler. Taking the number 2 spot is the New Holland 855 round baler, introduced in the mid-1980s and representing New Holland's mature round baler technology. As the company that had dominated square balers for decades, New Holland's transition to round balers was crucial, and the 855 showed they could innovate a new technology just as successfully as they'd refined conventional designs. The New Holland 855 used a fixed chamber design, different from variable chamber approaches. The baling chamber was a fixed circular space, and the bale grew to fill this space consistently. The advantage was simplicity and bale uniformity. Every bale was virtually identical in size and shape, making storage planning and feeding management easier. The belt system in the 855 was New Holland's perfected version of continuous belt technology. Multiple wide belts rotated through the chamber on a sophisticated roller system. Belt tensioning was automatic, adjusting constantly as the bale grew. The result was consistent bale density from core to surface, important for both storage and feeding quality. New Holland engineered the 855 with their crop retention system that minimized leaf loss during baling. For high-value hay like alfalfa, where leaves contain much of the protein and nutrition, this retention of leaf material significantly impacted hay quality and value. The 855's pickup system was extra wide, approximately 7 feet, allowing the machine to process windrows quickly. One feature that set the 8 and 55 apart was New Holland's one-button operation concept. Once set up, operators essentially monitored the machine and pushed one button when the bale was complete. The machine automatically stopped rotation, wrapped the bale, cut the wrap material, and prepared for the next bale. The 855 featured New Holland's advanced net wrap system, an alternative to twine wrapping that provided superior weather protection. Net wrap covered nearly the entire bale surface, creating a sealed outer layer that shed water extremely well. The 855 represents New Holland's successful adaptation to revolutionary technology. Number 1. Heston 4900 Big Square Baler. And taking the number 1 spot is the Heston 4900 Big Square Baler, introduced in the mid-1980s and representing yet another revolution in hay baling technology. While round balers were transforming small to medium operations, the 4900 targeted large-scale hay operations with a different solution: massive square bales that combine the benefits of traditional square bale shape with the size and efficiency of round bales. The Heston 4900 was an enormous machine, dwarfing conventional square balers. It produced bales that were 3 feet by 3 feet in cross-section and up to 8 feet long, weighing between 800 and 1,400 pounds, depending on crop type and density settings. These weren't small square bales you could throw. They required tractor loaders or specialized equipment to handle, but they offered unique advantages. The big square bale format combined the best of both worlds. Like round bales, they were large enough to dramatically reduce handling labor compared to small squares. But unlike round bales, they stacked efficiently for transport and storage. Square bales and trucks use space far more efficiently than round bales. They stack stable and secure for long-distance transport. Export hay markets particularly valued this. Big squares became the standard for container shipping of hay internationally. The 4900's mechanical system was essentially a massively scaled-up version of conventional square baler technology. It featured an enormous plunger, approximately 3 feet square, driven by a huge flywheel. The plunger stroked several times per minute, compressing hay into the bale chamber. Each completed bale was bound with multiple strands of wire or heavy twine. The power requirement was substantial. It needed tractors producing 120 to 150 horsepower minimum. The machine consumed enormous power compressing hay to the densities it achieved, but the density was crucial. Big square bales needed to be compressed more tightly than small squares to maintain structural integrity when handled with loaders and forklifts. The 4900 found its market primarily among large-scale hay operations producing for commercial markets. The machine's capacity was impressive. In good conditions, a well-run 4900 could produce 40 to 50 bales per hour, translating to 30 to 40 tons per hour. The big square format created entirely new markets for hay. Export shipping became economically viable because big squares use container space efficiently. The 4900 takes our number 1 spot because it showed that innovation in agriculture isn't just about new concepts. Sometimes it's about executing familiar concepts at scales nobody imagined possible. And there you have it, the top 10 most powerful vintage hay balers that revolutionized livestock farming. From the pioneering small square balers that freed farmers from pitchforks, through the round bale revolution that changed hay storage forever, to the massive big square balers that created new international markets. Each machine on this list transformed how farmers worked and how animals ate. Which one surprised you most? Do you remember baling hay with any of these machines? Or maybe you're still using one today? Drop your thoughts in the comments below. And if you enjoyed this journey through hay equipment history, don't forget to hit that like button. Share this video with fellow farming enthusiasts and subscribe for more deep dives into the machines that built modern agriculture. Thanks for watching, and we'll see you in the next one.